Today we are going to talk about Prim's algorithm. This is the very important algorithm used in many fields like computer science, network design, and electrical engineering. By the end of the video, you will be able to understand algorithm completely. First, we are talking about the main purpose of Prim's algorithm is to find minimum spanning tree. Now you can see example. Imagine you need to build a road network connecting five cities. It must be possible to travel from any city to any other city. However, you want to minimize the total construction cost. Such problems are solved using the prime algorithm. Key point on screen. Connect all locations. Minimize total cost. Ensure no circle are formed. Now you can see a real-world application for Prime's algorithms. First, network cable layout. When laying internet cable in a new building. Second, electrical grid design. Planning electricity supply to villages. Third, water pipeline systems. Planning pipeline routes. Transportation networks. Bus routes and highway networks. Last one, telecommunication networks. Connecting mobile towers while saving costs. Let's talk about the core concept for the Prime's algorithm. Prime's algorithm is a greedy algorithm. This means, first one, at every step, it makes the best choice for the present moment. Second one, in the end, this yields the best overall result. Imagine a beauty pageant. You must participate from all districts, but your travel budget is low. What you do this? First, from your current location, choose the best route. Second one, go to the location and again choose the next best route. Third one, repeat this until the all districts are covered. In the end, you have visited all districts. Your total cost is minimized and you didn't need to visit any place twice. Now I am going to show you the most critical part of Prime's algorithm, the age selection method. Once you understand this part, Prime's algorithm is in the palms on your hand. The golden rule for the Prime's algorithm. Prime's age selection rule. From all ages connect to the current tree, always pick the one with the minimum weight. In golden rule, you must three things to remember. There are first, must be connect to the current tree. Second, must have minimum weight. Third, must not create a circle. Now look at the frontier concept for Prime's algorithm. The fundamental concept in Prime's algorithm in frontier. All edges that connect the vertex inside the tree to vertex outside the tree. At every step, we update the frontier. Second, pick the minimum weight edge from the frontier. Last one, add into the tree. Now let's talk about the algorithm step. First step, choose any single vertex. This is the start of your tree. Second step, from the vertices already in the tree, select the edge with the smallest weight that connect to the vertex not yet in the tree. Third step, add that edge and its vertex to the tree. Last step, repeat step 2 and 3 until all vertices are included in the tree. Now let's break down Prim's algorithm into a simple, easy to follow step. I will show you a small example that makes everything crystal clear. Here is our simple example graph. We have four cities. There are A, B, C, D, and here are road distance between them. This is the example of graph appearance with weights. Our goal: connect all four cities with minimum total road length. Step 1. Choose any single vertex. This is the seed of our tree. Let's start with the city A. Now our tree in A. This is the like planting our first tree seed. Why I choose A? It doesn't matter which cities we start with. We could start with B, C or D and still get the same minimum total. Step 2. Find the smallest connection edge. From the vertices in the tree, find the smallest edge connecting to the vertex, not in the tree. Tree edges glow from A. There are B, C and D. Currently in tree A. Tree edges from A to outside. There are A to B, A to C, A to D. You can see a weight for these tree edges. Now we can get the smallest weight. Smallest weight edge is A to C. Its weight is 2. Step 3. Add that edge and its vertex to the tree. In step 2, we get the small weight of edge. It is the AC. Now city C. Add the tree. Now tree is the AC. Total length is the 2 units. Now you can see a tree grows from single point A to include C with the connecting branch. Step 4. Tree now has A and C. New available edges appear. Now tree is the AC. You can see edges with their weight. Available edges from tree to outside, from A to B and A to D, from C to D. You notice that point. We consider all edges from all vertices currently in tree. Now you can choose the smallest weight. The smallest weight is the CD. Its weight is the 1. Now add the edge CD and CTD. Now tree is the ACD. Total unit is the tree. Now you can see an example of tree after the step 4 second iteration. Final iteration of step 4. Now tree has the ACD. Only B remain outside. Available edges to B. Only outside city. From A to B. Its weight is 4. From D to B. Its weight is 1. Now you choose the smallest weight for there are 2 edges. You can see a small weight is the D to B. Its weight is the 1. Now add the edge DB and CTB. Now tree is the complete. Total unit is the 4. Now you can see the complete tree after the final iteration of step 4. Total weight is the 4 units. Common mistake and tips. Mistake: creating circle, inefficient implementation, disconnected graph. Tips. These tips use to avoid these common mistakes. There are always check the visitor status. Use the priority queue. Ensure the graph is connected. Comparison with Kruskal algorithm. This table shows the difference between the Prim's algorithm and Kruskal's algorithm. Prim's algorithm is vertex based, but Kruskal algorithm is edge based. Prim's algorithm data structure is priority queue. Kruskal algorithm data structure is union find. You can see many advantages and disadvantages for Prim's algorithm and Kruskal's algorithm. Now we will learn Prim's algorithm by planning real road network between Sri Lankan cities. We will connect 5 cities via 7 roads, covering all cities with the least possible total distance. We have 5 cities. There are Colombo, Kandy, Gala, Anuradhapura and Trichinopoli. We use the first letter for easier to understand for these cities. Problem is find a road network that connect all cities with the minimum total distance. Now you can see a road distance. We have 7 different road distance. We use the first letter of cities for easier to understand. We can consider the road distance, value of the edges. This is the visual of the complete graph. We use this graph find the road network that connect all cities with the minimum total distance. Step 1. Start with any city. We choose a Colombo city. Now we have a Colombo. Connected city is the Colombo. Total distance is the 0. Colombo with 3 roads radiating out. There are Colombo Kandy, Colombo Gala, Colombo Anuradhapura. Step 2. Choose the road with minimum distance that connect to our tree. We have 3 available roads from tree. There are Colombo to Kandy, Colombo to Gala, Colombo to Anuradhapura. Now we can choose the minimum distance with the road distance. We can get the Colombo to Gala. Now we have 2 cities. There are Colombo and Gala. Connected city is the Colombo and Gala. Total distance is the 100 kilometers. Step 3. Now tree has the Colombo and Gala. New road appear. Available road from the Colombo and Gala. We have 5 roads available. There are Colombo to Kandy, Colombo to Anuradhapura, Gala to Kandy, Gala to Trichinopoli, Gala to Anuradhapura. Now we can choose the minimum distance from these road distance. We can get the Colombo to Kandy. Now we have Colombo, Gala and Kandy. Connected cities is 3. Total distance is 220 kilometers. Step 4. Third road selection. Now we have Colombo, Gala and Kandy. Available road from the Colombo, Gala and Kandy. We have 5 road distance available. There are Colombo to Anuradhapura, Gala to Trichinopoli, Kandy to Anuradhapura, Kandy to Gala, Colombo to Kandy. We cannot get the Kandy to Gala and Colombo to Kandy because Kandy, Gala already in the tree and Kandy already in the tree. Now we can choose the minimum distance from the road distance. We can get the Kandy to Anuradhapura. Now tree have Colombo, Gala, Kandy, and Anuradhapura. Connected cities are 4. Total distance is 350 kilometers. Step 5. Final road selection. Now, tree have 4 cities. It is Colombo, Gala, Kandy, and Anuradhapura. Only Trigunamale remains unconnected. Available road from the Colombo, Gala, Kandy, and Anuradhapura. 5 roads available. There are Colombo to Anuradhapura, Gala to Trigunamale, Kandy to Anuradhapura, Anuradhapura to Trigunamale, Colombo to Kandy. But we can get the 2 road distance. There are Gala to Trigunamale and Anuradhapura to Trigunamale. We cannot get the Colombo to Anuradhapura, Kandy to Anuradhapura and Colombo to Kandy because Colombo, Anuradhapura, Kandy already exist in tree. Now we can get the minimum distance. We can get the Anuradhapura and Trigunamale for minimum distance. Now tree have completed. All cities connected. Total distance is 416 kilometers. This is the final results verification. Minimum spanning tree. For MST. Colombo to Gala, Colombo to Kandy, Anuradhapura to Trigunamale and Kandy to Anuradhapura. Total distance is 460 kilometers. Now you can see a final tree visualization. All cities connected. No circle. Minimum total distance. Now you can see a cost saving calculation. Complete network distance is 990 km. MST distance is 460 km. Distance saved 530 km. Percentage wise is 53.5. Now you can think if your road construction cost is 10 million per kilometer, complete network is a 9,900 million. MST network is a 4,600 million. Money saved rupees 5,300 millions. This is the video end. Today I explain the purpose of Prim's algorithm, explain the minimum spanning tree, and explain the real-world example for Prim's algorithm. Thank you for watching my video. See you soon next new video.